So the chemical reaction gives us conversions between moles of reactants and moles of products, which is awesome. But we can't directly measure moles of compounds or elements, right? We measure things by their mass. So we're usually more interested in relationships between mass of reactants and mass of products. So how do we do that? Well, here's the big idea right here. This is what we just learned how to do, to convert moles of one thing to moles of another. If you have 5 moles of A, how many moles of B could you make? And the ratio from the balanced chemical equation is the conversion factor. That's what we were just doing. Well, how many grams is that many moles? The mass to moles we have also learned how to do. That's the molar mass. For an element, you just read it off the periodic table. For a compound, you see how many atoms of sodium and how many atoms of chlorine and how many atoms of this, and you add them all up to get the molar mass. That's the conversion factor going from mass to moles. We always have to go to moles in the middle because that's what the balanced chemical equation shows us, is how the numbers of atoms relate to each other. And then at the end, we convert moles back to mass. So this should be a little chant that you chant to yourself: grams to moles to moles to grams. That's the secret to stoichiometry right there. Grams to moles to moles to grams. And you know that you've said it to yourself enough when you're dozing off at night and you're thinking grams to moles to moles to grams, right? That's the path. So this is going to be dimensional analysis, and we're going to be converting units, and there's going to be 3 steps. But the path is always essentially the same. It's grams to moles to moles to grams. And I won't make you chant it out loud. So let's do an example. So here we have octane burning in a car, and in the engine it's supposed to be burning, and it's making carbon dioxide and water. What mass of carbon dioxide is emitted for every 5 times 10 to the 2 grams of octane? So here's a mass of a reactant, and we want a mass of a product. So you can use that balanced chemical equation as sort of a guideline to keep track of things. So we read through this question: what mass of carbon dioxide? So find carbon dioxide in the equation. Well, here it is, CO2. And then under that, I'm going to write question mark grams. That's what I'm trying to find. Buy an automobile per 5.02 grams of pure octane. Okay, we have not learned how to write the formula for octane, but you should be able to figure out by process of elimination, okay, that's oxygen, that's carbon dioxide, that's water, so therefore this must be the octane, right? So I'm going to write the mass that they gave me under that. 5.02 times 10 to the 2 grams. So on your paper, you should write out the balanced chemical equation. It'll be given to you. And then you put question mark grams under what you're trying to find, and the mass that they give you under the thing that it belongs to. And that gives us our idea of what we're doing. We're starting with the number. So we're starting with grams of C8H18, grams to moles to moles to grams. We're going to convert grams of that to moles of that. And then we're going to convert moles of that to moles of the thing that we're interested in. And then we're going to convert moles of the CO2 to grams of CO2. Grams to moles to moles to grams. How do we know which one to start with? The one they gave you the number for. Okay, that's the one you're starting with. How do we know what we're going to? The one they're asking you the question about. How many grams of carbon dioxide? What mass of carbon dioxide? Now notice, in this first step, I'm converting between grams of octane and moles of octane. The unit is changing, but the compound is not. In the middle, I'm going from moles of octane to moles of carbon dioxide. The unit is staying the same, the compound is changing. And then in the last step, moles of CO2 to grams of CO2, the unit changes, the compound does not. You can only change one thing at a time. You can change the unit for the same compound, or you can change the compound but use the same unit. So there's our path, and now we just follow what we learned about dimensional analysis. So 5.0 grams, 5.0 times 10 to the 2 grams, and you need to write C8H18. I have 3 arrows. I'm going to have 3 fractions. Times. The units here in our path are what go on the top. So we're starting with grams of C8H18. The next one is moles of C8H18. Next is moles of CO2. And last is grams of CO2. Leave a little space in there because there's going to be some numbers. You see, I wrote this path down, and that tells me what to do here. Grams C8H18 to moles C8H18 to moles CO2 to grams CO2. Exactly what I had up there. Now I need to put units in the bottom. The unit in the bottom is just the previous unit. I need this unit to go away, so I'm going to divide by that. So grams C8H18. Those guys then cancel out. Over here, I'm going to put moles of C8H18 in the bottom so it can cancel the previous term on the top. And at the end, I've got moles of CO2. Any questions? We get all the units in there first, and then we put numbers in. And you can do the numbers in any order. You can do the last one first or the middle one first. I like to do the middle one first because it's the easiest. There's no calculating involved. Moles of one thing to moles of another, that's what we just learned how to do. Those numbers come directly from the balanced chemical equation. What number's in front of C8H18? It's the number 2. So then down here, in front of moles of CH818, I'm going to put the number 2. And in the equation, CO2 has a 16 in front of it. So then in this conversion factor, I'm going to put a 16 in front of CO2. And yes, you could simplify that if you want to, but I don't see the point. Just punch it through on your calculator. It'll be good. We've learned how to do these. This is molar mass. And I would encourage you to write them out, because then if you make a mistake, you can go back and see what you did wrong. So C8, that's 8 carbons at 12.01 and 18 hydrogens at 1.008. 8 times 12 plus 18 times 1.008. 114.224. Did anybody else get that? That's grams of C8H18 equal to 1 mole of C8H18. It's always number of grams for 1 mole. that number does not have a crazy amount of significant figures or digits. You know, if it had 8 decimal places, I probably wouldn't copy them all down. But it's only got 3, so I'm just going to put it in there. No. No, you're not supposed to times it by the 2. Excellent. Excellent question. Question is, why don't we multiply it by 2? This tells us that we have 2 moles of C8H18 reacting this equation. But that 2 shows up here. Okay? What we want here is the mass of 1 mole. The coefficients get used in the center term and in the center term only. There are ways to do the 2, but it's going to make your life more complicated, and it's really not a good path to go down. So thank you for asking that. And then we need the CO2, which I believe is 44, but we'll work it out. 12.01, 1 carbon, and 2 oxygens. And that should be 44.01 grams of CO2 equal to 1 mole of CO2. So that's going to go into this last term here. Grams is on top, so that's where the number goes. 44.01 and 1 mole on the bottom. Again, we're not multiplying that out by 16. So now we've got 5 times 10 to the 2, and I'm going to divide by 114.224. I'm going to multiply by 16, divide by 2, multiply by 44.01. And I'm going to stick this number up here. So my calculator is showing me 1,541.18224. That would be grams, because the unit that didn't get canceled out was grams of CO2. So how should I express that answer? How many significant figures should I have? I should have 2. So is that 15 grams? No. So we need to put that in scientific notation. So we're going to keep the 1 and the 5. So that's 1.5 times 10 to the 1, 2, 3. 10 to the 3rd grams of CO2. Any questions? This is the typical mass-to-mass stoichiometry problem. It's a very, very central part of chemistry. Because when we do chemical reactions, the compounds and the elements react by numbers of atoms and numbers of molecules. But we can't measure them that way. We have to measure them with mass. And so we end up doing these all the time. Let's do another one. We'll do this one a little faster. What mass of octane would be needed to generate 42.3 grams of water? The way the question is asked may vary, but it always comes down to they give you the mass of one thing, they ask you for the mass of another. It doesn't matter whether they're both reactants, both products, one of each, it all ends up being the same. So I'm looking for 42.3 grams of water. So under water, I'm going to write 43.2 grams. The question is, what mass of octane? So question mark, grams. So this time I'm starting with grams of H2O, and I'm going to moles of H2O. And the thing I'm interested in calculating this time is the octane, grams to moles to moles to grams. You see how I'm doing that? When you can see the pattern, it's not that complicated. If you don't see the pattern, it looks like a big old mess. 42.3 grams of H2O. And I'm going to have 3 terms. And on the tops of those fractions, it goes grams H2O to moles H2O to moles of octane. And yes, it's tedious to write out all those formulas, just do it anyway. 2 grams. This unit goes in the bottom because I want it to go away. Grams H2O, those are going to cancel out then. Over here in the bottom, I want moles of H2O. See, the units are just telling us what to do. They're almost screaming at us. Can you hear them? They sound like a tired 5-year-old. I'll tell you stories about him. All right, it's getting smaller and smaller. Zooming in too far. We get all the units in place first. Grams to moles to moles to grams. We work them out so that they cancel each other out. And the unit that's left standing is the unit we're asking about, mass of octane. Now we put numbers in. The middle one's easy. What number is in front of H2O in the equation? It's an 18. So I'm going to write an 18 in there. In front of the octane is the number 2. That's the only place you're going to use those coefficients. Do not use them in the other terms where you're calculating. So, water is 2 times the mass of hydrogen plus the mass of oxygen, which is 18.02. So 18.02 grams is equal to 1 mole of water. And we already did the octane, right? That was 114.224. And then you use your calculator. It's best if you're organized about this. I just go left to right and go straight across. Personally, I don't like multiplying and dividing by 1, but if you like to do that, you can certainly do that. So I'll say this one with the 1s in there. So that'll be 42.3, got to enter that right, 42.3 times 1 times the top, divide by the bottom, divided by 18.02 times 2 divided by 18 times 114.224 divided by 1 equals. And then the calculator shows me a big mess, but I'm going to look at how many sig figs did I start with. I started with 3, and so I'm going to end up with 3. So I'm going to round this off. It's going to end up being 29.8 grams of C8H18. Yes?
I don't know if it's possible or not, but if one of the other numbers that we use in the equation is smaller than the original number, do we use those sig figs?
Yeah, so the question is, what if one of these numbers has fewer sig figs than what we're starting with? Yes, you would use the smallest. Now, if they gave you one here that had 6 significant figures, and you only calculated your masses to 4 significant figures, then that would limit it. Generally, in the book, and the same people that wrote the book wrote the test bank questions, they're usually going to give you masses with 3 significant figures, and so that will mostly limit. So that's like a pretty sure shortcut if you're one of many people who hate significant figures, right? Just however many you started with, that's how many you end up with. That's usually pretty safe. Good question. Any other questions? Do you think we need another example? Yeah? Okay. So sometimes, I don't know if they're trying to make this easier or they're trying to confuse you. Magnesium hydroxide, the active ingredient in milk of magnesia, neutralizes stomach acid, primarily HCl, according to the reaction. Do we really need that sentence? No. It's backstory. Here's the equation. We've got the equation. Now, usually they're going to give you a balanced chemical equation. Always a good idea to double check. Usually if there's coefficients given, you can assume that it's balanced. But it's possible they might try to trick you. Here's the real question. How much HCl in grams can be neutralized by 5.50 grams of magnesium hydroxide? So how much HCl? That's the question. Question mark, grams. And then they're giving us 5.50 grams of the magnesium hydroxide. So it's always grams to moles to grams. Grams to moles to grams. Grams of whatever they gave you the number for, to moles of that, to moles of the other thing, to grams of the other thing. And so we end up here with 5.50 grams of magnesium hydroxide. And we're going to multiply by moles of magnesium hydroxide, because we're going grams to moles. And then we're going to change that to moles of the thing we're interested in, which is the HCl. And then grams of HCl. So I cheated a little bit here. I didn't write the compounds in here. But this is what we're starting with: grams to moles of this, to moles of that, to grams of that. And so that's all written out here. Do not leave those out of this equation here. If you don't write down grams to moles to grams, you may be just fine. This part down here, you should write down every single time, no matter how good you get at this. I still write it down. Okay, I could do it without, but sometimes it just turns out badly. Okay, so just do it. So then in the denominator, grams. Oh, that's really sad there. H, the 2's on the outside. Sorry about that. And over here, we've got moles of magnesium hydroxide. And down here, we've got moles of HCl. And so we make sure that our units are canceling out. They actually have to cancel out. You can't do what I call wishful unit canceling. Well, I wish they would cancel out, so I'm just going to go cross them all off and hope for the best. Now, the middle one. I like the middle one because it's easy. HCl. In front of HCl is the number 2, so I'm going to put the number 2 there. In front of magnesium hydroxide is nothing, but that means there's a number 1 there. So I'm going to write a 1 down here. So we need magnesium hydroxide 24.31 plus 2 times oxygen plus 2 times hydrogen. And if I'm concerned about getting the answer right, I actually write this part down too, just because when you write it out, then you don't forget things when you put it in your calculator. It actually saves you time in the long run. 24.31 plus 2 times 16 plus 2 times 1.008. Come up with 58.326. So that goes in here, 58.326. And then HCl is 1.008 and 35.45, which ends up being 36.458. .50 times 1 divided by 58.326 times 2 times 36.458 equals, again with the 3 sig figs, so 6.88 grams of HCl. Did anybody else get that number? Yes. Okay, when you're doing calculations like this on your calculator, this is not just one little thing, it's just a bunch of things strung together. Do it twice, because it's so easy to make a little mistake. If you do it twice and get the same answer, the chances are good you did it correctly. Any questions? I don't know about you, but I'm done. I'm done with these exams.